All right, section 2 starts talking about solving a triangle. And when we talk about solving a triangle, we're talking about solving a right triangle. And solving a right triangle means that we find values for all of the side lengths as well as all of the angles. And we have what we call standard lettering. For triangles, for right triangles when we're solving. And standard lettering means that A, B, and C represent side lengths. Notice it's all capital letters. A, B, and C represent angle measures. The biggest difference, well actually the only unique thing about this is that C, capital C, is always the hypotenuse. Sort of like with the Pythagorean theorem. So for example, actually let me erase this so we have some room. So for example, if we have the following triangle, and again, we're only talking about right triangles. Here's our right angle. And we know that this is A, this is B, this is C, this is A, B, I can't remember what I just wrote on the board, but I think I had them inverted. Capital letters are for angles. In fact, I'm pretty sure I had them inverted. I'm sorry. Little letters are for side lengths. And this little c is the hypotenuse. My apologies. Okay. So here we want to solve this triangle. Well, that means that we need a value for capital A, capital B, capital C. We also need a value for A, B, and C. So let's fill in what we already know. We already know that angle A is 61.7 degrees. We know that length C, notice that each side is opposite the corresponding angle. Okay, so we know that this is side C, is 106.2. The unit is irrelevant at this point for a minute. And that's all we have. So we need to figure out how long B is, how long C is, and the angle of measure, or length of A and B, and measure of angle B and C. So we're going to use our trigonometric functions. Let's start by finding the lengths of sides A and B. So we know the hypotenuse, and we're going to look for the opposite side first. So the trig function that deals with hypotenuse and opposite is sine. So for the length of side A, we're going to take the sine of the angle 61.7, and we're going to set it equal to A divided by the hypotenuse, which is 106.2. Use your algebra skills, find the sine of this first, multiply both sides by 106.2. And at this point, it's okay to make approximations. We'll start working on exact values shortly. And we end up with A having a measure of 93.51. And right now, again, don't worry about the units. Okay, so for side B, we're going to use the cosine function because cosine is adjacent and hypotenuse. So we want to take the cosine of angle 61.7 degrees, And we're going to set that equal to side B divided by 106.2. So again, using your algebra skills, find the cosine of this first, multiply both sides by 106.2. And we end up with B being a length of 50.35. Just do a quick double check visually. C should always be the longest side because it's the hypotenuse. A is clearly larger than B, and we calculated it to be as that way. All right, now, probably the easiest thing to find the measure of angle B. Well, measure of angle C is 90 degrees. We know that because of the symbol there. What I would do for B is actually just use the fact that the sum of the angles of a triangle is 180 degrees. So I would probably say, okay, B is equal to 180, we're going to subtract 90, and we're going to subtract 61.7, which means that the measure of angle B is 28.3 degrees. Now, just again, a double check. The smallest side length should have the smallest angle. The largest side length should have the largest angle, so keep that in mind. There are a lot of really great examples in section 2, even some scenarios, but it's all the same business, and probably serve you well to go through those examples. If you have any questions, email me.